Hello everyone, WD0AKX Larry here. Gonna build a dipole. It's gonna be a multi-band dipole. Some people call it a fan dipole, but I want to stick up another antenna here on the tower before winter. Something to play around with, and compared to my other antenna, I guess it might give me an advantage in certain directions over my other antenna. So let's see what we can do here. Let's get started. Well, to start out with, here's some of the parts I've been gathering up to make my fan dipole. I do have some of this stuff I've had around. I've got some insulators here that I can use. I also had these insulators here, and I'll probably be putting some or all of them to use. Now, I did have a center insulator that I was going to use, and it looks like it may even be a Ballon. There's nothing labeled on it, but it's pretty old. I remember using this many years ago, and offhand I don't remember if it had a problem and I took it down, or what kind of shape it's really in, and it's pretty weathered. So what I decided to do there is just start fresh with a new insulator, center insulator. So I ordered one. I ordered a couple things here from Amateur Electronics Supply that I can start fresh with. So this ought to be a decent center insulator for my dipole. And I do have some wire around here, but for the longest leg of my dipole in the 40-meter section and the 20-meter section of my fan dipole, I decided to order some new wire. So I got 100 feet of this 13-gauge poly stealth with the black jacket from Amateur Electronics Supply too. They had that on hand. So I decided to get 100 feet of that, and that will work for the 40 and 20 meter leg of my fan dipole. For the other bands, it won't require that much wire, and I do have various shorter lengths of wire on that I'll probably put to use along with this. And I do have some coax seal on hand, but maybe not enough, so I ordered one more package of coax seal to help seal up any connectors. And the rope I had around here looked pretty weathered too, so I ordered some new antenna rope. I got 100 feet of 3/32 inch diameter, the double braided polyester antenna rope. So that should hold up to support the ends of my dipole. So that's what I come up with here so far. So I guess we'll start assembling the antenna and see how far I go here before I need something else. Well, the multi-band antenna that I'm going to build will look similar to this, and some people call them fan dipole, I guess, and otherwise it's a multi-band antenna. And what it is basically is just a separate dipole cut for whichever band you want to use, and they all have a common feed point, so you could run one coaxial line into your ham shack, and it's just several dipoles all connected at one common point, basically, is what it is. So what I'm going to do, I'm going to cut my dipoles for the bands I'm interested in with this antenna. I think I'm going to go with a 40-meter antenna and then a 20-meter. And the 40 meter will actually work on 15 meters also, since it's a third harmonic. And I'll probably add a 10 meter dipole, and I think I'm going to add a 6 meter dipole. So I don't have a 6 meter dipole up very high in the air, so I think I'm going to add a 6 meter element there. So it's a half wavelength, and to calculate the length of a dipole, you take 468 divided by the frequency in megahertz, and this is out of my ARRL antenna book here that I'm looking at right now, but that's the formula for calculating your half wavelength here, total length for whichever band you want to use. So 468 divided by your frequency, and that will give you the length of each dipole. And then you cut it in half and connect one side of the coax cable to the wires on the one side, and you connect the braid side of the cable to the other side. Now I think I'm also going to add a Ballon in line right up near the coax here to kind of keep the RF, keep the feed line from radiating, keep the RF off the feed line. So I'll probably do that. So let's see what we can come up with here. One more thing to keep in mind is that the wires should be separated a little bit, one element from the other. You don't want the wires right next to each other, so I'm going to make spacers, and kind of like they show here, or just to keep the wire, each element separated. If you're pruning an antenna on one band, it will affect the other. All the elements will interact somewhat, so if you're using an antenna tuner, nothing to worry about. If you have the elements close in frequency, the tuner will make your rig happy, and the antenna is still going to radiate well since the elements are close in length. But if you want to actually tune it so you don't have to use your antenna tuner, it might take some work to work between the bands going back and forth, because one element will interact with the other. So space them apart, and they'll interact a little less that way. And you could also run them off in different directions. You know, looking down from above, you could have a 40 meter dipole going this way and a 20 meter this way off the center. So that's another possibility, but I think mine will all be in a north-south direction here. The antenna radiates best off the side here, broadside to the dipole, so it radiates less off the ends. So just a rough sketch of what I'm talking about here. I'll have my 40 meter, 20 meter, 10 meter, and 6 meter elements, and each one will be a little shorter than the other for the different bands. And I'll put some kind of insulators in here, maybe short sections of some small PVC or something. I'll figure that out later here, but I'll probably just have a few sections separating those wires from each other, and that should work fine. And also, as I was mentioning a little earlier, looking from the top down, you can space your elements that way. So like you'd have the 40 meter running this direction, looking down, and maybe your 20 meter that way, and your 6 meter this way, whatever. You can have them all in various directions, and that separates them even a little better. But I think mine will all be in a straight row, running one direction. That's the way that works the best here for my property, and also for the direction I want my signal to radiate best, east to west here, since I'm in kind of the central part of the states in Minnesota. And now looking from the top down again at a dipole antenna that's cut for a half wavelength. You have a quarter wavelength on each side. The whole thing makes up a half wavelength, but the signal will radiate best kind of off to the sides like that. So your maximum signal will be broadside to the wire. This is looking down at the wire. And you'll have the weakest signal off in these directions. Okay, I just made a quick diagram here. Hope you like my drawing. Just made a quick diagram of the dipole here with the different frequency bands on it. And down here I did the calculating for length using the frequency 468 divided by your frequency in megahertz. I decided what bands that I wanted to use here, 40, 20, 10, and 6, and the 40 will also work on 15 meters, so that's a bonus. But the 40 meter band is 7 megahertz, 20 is 14 megahertz, 10 meters is 28 megahertz, 6 meters is 50 megahertz. Well, the actual frequency I want to use is up in the band a little ways. I didn't start at the very bottom of the band, so I'm going to do my calculating like at 7.1, 14.2, and 28.2 megahertz. So using that formula, I get a total of 65.9 feet for the total length now on 40 meters here. That'll be the total half wavelength of the dipole. And you divide that by 2, so I get 32.9 feet on each side for each leg of the dipole. So from the center insulator out on each side, that would be my length. I did the same thing for 20 meters. You get 32 feet 9 inches, or 32.9 inches. Excuse me there, for the total length of the 20 meter dipole, and 16.6 feet for the 10 meter total length, 9.4 feet for the total length of the 6 meter dipole. And then each leg for the 20 meter, 16.5 feet on one side, 8.3 feet on one side for the 10 meter, 4.7 feet on one leg of the 6 meter. So that's kind of how it works, how you calculate it. Now you can pick other bands, you can add whatever bands you want onto this, and you don't have to use 4 elements. You could just use 2 bands if you wanted, or you could add a 5th band. So you can mix and match, but the main thing is you have a dipole for each band that you want to use and connect them in the center. I decided to make a ballon here, homemade ballon for my fan dipole. And if you search in your search engine, look up ugly ballons, you'll find several examples of these. You can build your own ballon, save a lot of money. If you don't want to buy one, if you don't have everything on hand you need, you can always purchase one. But I happen to have a section of PVC pipe here, 2-inch diameter approximately, and about 15 inches long, just what I had on hand. So I'm gonna see if I can wind the length I need here. And what you need is, to make your ballon, you need about 20 feet of coax cable, whatever you have. They say somewhere between 18 and 21 feet is kind of the magic length to make a ballon. So I measured out 20 feet, and I'm going to see if I can wind that on this tube here. We'll see how I come out. So the ballon should help kind of isolate the RF from the feed line, keep the RF from being radiated by the feed line or coming back into the shack. So that's what I'm going to try to accomplish by building the ballon here. Alright, my ballon is just about complete here, and I've got my cable all wound. Ended up being about 37 turns, I think, something like that. But the main thing is there's 20 feet of cable here is what I have that's wound up on the coil. And I was able to cut a little bit off the pipe. It's now 1 foot long, 12 inches long. As you can see, the coil part itself takes up about 9 inches on my 2-inch diameter form here. So I was able to cut a little off. And I went ahead and put some clamps to take a little strain and kind of hold the cable in place. Now as I was winding it, I put some duct tape on in sections as I got so far, just to kind of hold it as I was going. So now I'm going to put some more tape over this, and I'm going to put a good quality like a 3M black tape around this, something that'll withstand the weather, and get this taped up good, and then I'll have my complete ballon. This will connect to my center insulator, and I've got a lot of cable there left to work with to come down my tower, and I'll probably end up chopping half that off or so. Here's the completed ballon. I finished wrapping it with a good black tape, so should be fine. Alright, we'll skip ahead in time here a little bit. I got my wires cut now for each band, and then I can go ahead and solder them up to the center insulator here. And this center insulator has an SO239 connector on the bottom of it, so I can just screw my PL259 connector onto that when I'm done. But it has bare wires coming out each side, so I can solder the wires from each band here. So these are the wires for one side, and I have the other wires over here for the other side. And by the way, the longest wire here is my 40 meter wire. This next one is my 20 meter, and getting a little shorter, my 10 meter, and then my 6 meter wire. You can see it's getting fairly short there now at 6 meters. And I was thinking too that I might not have had to add the 6 meter wire actually, since 6 meters it's an odd harmonic of 40 meters. The 40 meter antenna may work okay itself for 6 meters, but I'm going to go ahead and put this dipole on there anyhow. It's fairly small anyhow. Alright, now I've got the wires all soldered up and ready to go. I guess I might put some black tape around the solder connections here. I'll decide that in a little bit. Alright, I'll show you what I have so far. I have my center insulator with my wire connected, my antenna elements all connected, and I have my PL259 connector on my cable that comes from my ugly ballon. Actually, it's not a ballon like I said before. It's more of an RF choke. It's designed to keep the feed line from radiating or any RF coming back down the feed line into the shack. This will go to the shack, and this will tend to choke that off. So it's not truly a ballon. A ballon is made to kind of balance or match a balanced antenna. A dipole is a balanced antenna to an unbalanced line like a coax, which is an unbalanced cable. Alright, I brought the antenna out in the garage here now to kind of lay it out a little bit on the floor so I can spread things out a little. And at PVC pipe there, 1/2 inch PVC, 10-foot length. I just went down to the hardware store and picked that up for a little over $3, and I intend on cutting that up into sections to use maybe as spacers on the between the wires there. So I'll play around with that now here next. Okay, I went to the next step here and I started cutting my PVC up into sections that I thought would work. And as you can see, if you can see very well here, still laying on my garage floor, but I do have the PVC insulators in place there, kind of how I think I'm going to end up with it. And I've just kind of been experimenting as I go and cutting them as I go to see here, and I think I come out with something that'll work good. Now I think I'm going to take them back off there now and probably put some gray primer on them. They're kind of bright white and they'll stand out up there off the tower a little too much. I think if I paint them that gray, it might help a little bit to hide them. You know, they'll blend in with the sky a little bit better. I'm going to think about that. All right, next. Spraying down the PVC here. Just got them on a piece of wire so I can spray them all down at once. Didn't know I was going to do this at first, so otherwise I could have sprayed them all down in the beginning. And I also shot a little primer on the ends here after I brought it back in. Alright, I have my spacers primed and I have everything kind of spaced out somewhat evenly here. And now I'm going to take the glue gun and just kind of touch up where each wire goes through each spacer there. Alright, I have the hot glue in place and everything pretty much wrapped up here. I'll show you a little bit on the dimensions if you're interested. I ended up using a total of 11 of these spacers per side on the dipole. So I started out with 4 that are 7 inches long, and my spacing is 16 inches here on the first 3 sections, and then I go to a spacing of 22 inches, and I started using spacers that are 5-inch long, and I used 2 of those. And then as we get out farther, I changed my spacing to 19 inches with 3-inch long spacers, and I used 5 of these 3-inch long spacers for the rest of the antenna here. And then I did put a center, or not a center, but an end insulator on right there. Now, these dimensions aren't critical or anything for the spacers. It's just kind of what I ended up with to make them somewhat evenly spaced, and what seemed to work good to space the wires out for me here. Well, I think I've got the antenna ready to go up the tower here, so I'm going to try to go up there today, and got my climbing belt and safety gear on here for going up the tower. So see if we can get this antenna up today. Just kind of looking around a little. Well, I don't know if you can see it very well or not. This is how I ended up going with the choke up here. Get it away from the tower a little. And yeah, look at those trees out there. Real pretty this time of year. This is looking down, and I haven't got the dipole up yet, but just kind of hooking things up here. There's looking down towards the roof and the ground. hazer. It's my VHF TV dipole there, the white one, and my UHF TV antenna. Yeah, just to prove I'm up here, here I am, my mug shot by the tower. Well, there it is, completed, hanging on the tower, if you can see it. And it goes back down into that tree. It ended up being like an inverted V type dipole. And it goes down to a roof vent. And the wire, other wire just above it there, that's my off-center fed dipole. So there it is, the completed antenna. Inverted V style. Okay, I'm down on the workbench and I have a cable run down here right now to test the antenna. So, analyze the SWR here. Right now, I'm on the 4 to 10 scale, and it's pretty hard to see the numbers here, but as you can see, I'm right above 7 megahertz there, and I get a dip. It's high, and then I come right in there, and I get a nice dip, and that is just a little above 7 megahertz there. So that's good on 40. It's resonant right on the band, looks like. Let's go up here to 20 meters. And there's our dip. And it's showing me just a little bit above 20. High end of 20 meters. So the low end of 20, it's a little high. So I could make some adjustments, but like I say, the antenna tuner will bring that in okay with the radio. That'll be fine. It's close enough. Let's go up here. Try let's see, no, let's stay back here. Let's try 15 meters up by 21 megahertz here. There's our dip, and that's little up above 21 megahertz, about 23 there showing. So I'd have to maybe make some adjustments there, but close enough. The antenna tuner will take care of that. Let's go up, check 10 meters here. There's a little dip there up about 35. Let's keep going. There's our dip right above 28 megahertz. Perfect. Nice dip there on 10 meters. So we're doing good. Let's go up to 6 meters. Way at the top end here. Right in there. Oh, a sharp dip right there at 6 meters. Just above 50 megahertz. So it looks like the antenna was a success as far as tuning. So I'll have to check it now on the air and play around, see how it goes. Alright, I'm down in the shack here and playing around with the antenna that I put up, comparing it to my other antenna, which is an off-center fed Wyndham style dipole. So it seems to be working well here so far. Signals are very strong on the new antenna, so I know it's going to work okay. And just comparing both antennas, switching back, listening to different stations, pretty much what I figured. On some stations, one antenna favors the is a little better than the other one, vice versa, depending on the direction that the station is located from here, because the antennas do have lobes and they favor certain directions. So I think the antennas will kind of work good together. I can flip back and forth and use whatever the one that's working best for the signal I'm listening to or talking to at the time. I guess it'll give me another option here. So on some signals, one station might be 40 over on the new antenna, and I flip over to the other Wyndham antenna, and it might be 20 over. And station in another location, it might be just totally opposite of that, where the Wyndham style antenna is receiving better. So, thanks for watching the video. Hope you got some use out of it or enjoyed watching it. Maybe you got a few tips out of it. And keep watching. I'll say 7-3 WD0AKX.